Hello, welcome to the video on solving one-step equations. This is our fourth example set D. And what we have here is a short little word problem that's going to involve a one-step equation to find the answer. Okay, so let me go ahead and read the problem to you, and then we'll talk about how to do it. It says, in physics, the formula for force is F equals ma, okay? Or rather, force equals mass times acceleration. And force is generally measured in newtons, okay? Mass is generally measured in kilograms, and then acceleration is generally measured in meters per second squared. And the reason why I say generally is because there are other units, but these are the ones we're going to stick with in this particular problem. So the question is asking us the following. It says, how fast would a 500 kilogram horse have to accelerate? Okay, have to accelerate to create a force of 14,000 newtons. So the question is asking us, how fast would the horse have to accelerate? It's asking us to solve for A. Okay, now if you notice, we're given the force. Okay, we want to create a force of 14,000 newtons. Okay, so we're given that. We're also given that the horse weighs 500 kilograms, so we got the mass. So what we're going to be looking for is acceleration. So we're going to be plugging in these values and solving for A. Okay, so we look at our horse here. It looks like it's having a tough day, and I think all of us would if we had to drag somebody around the city. So our horse is, once again, 500 kilograms, and we want this horse to take off at some sort of acceleration to be able to create 14,000 newtons worth of force. So let's go and plug this information in, then we'll solve for acceleration. So force equals mass times acceleration. If you haven't studied this formula in science yet, you certainly will. Probably like in a physical science class, definitely in physics, because that's what this is. So we want to be able to create 14,000 newtons worth of force, okay, from a 500 kilogram horse. So this will be 500. That's our mass. Okay, so our force is 14,000 newtons. Okay, our mass is 500 kilograms. And how much would we have to accelerate this 500 kilograms to get 14,000 newtons worth of force? So we have to solve for A. So this is a one-step equation. So we have 500 times A equals 14,000. Now, if you don't like the way this looks, it's equivalent to this. 500 times A equals 14,000. Sometimes students get a little hung up that the variable's on the right-hand side. It doesn't make a difference whether the variable's on the right-hand side or the left-hand side. The same procedure is still going to take place. Okay, so how do we solve for A? Okay, what did we learn in the lesson to solve for this variable? Okay, well, we're going to have to use an inverse operation, and that is, because this is multiplication, because this is 500 times A, we're going to have to divide both sides of the equation by 500. So we'll get A is equal to 14,000 divided by 500. So if you haven't done that already, you want to go ahead and grab your calculator. 14,000 divided by 500 is equal to 28. Okay, but 28 what? Well, 28 represents acceleration, so you always want to use the proper units of measure. So that would be 28 meters per second squared. Okay, so when you're solving a word problem that has units of measure involved, whether it's newtons, inches, feet, miles per hour, always make sure you add in the proper unit of measure. Okay, so this horse is going to have to go 28 meters per second squared to reach a force of 14,000 newtons. And if you think about that, 28 meters per second squared, that's pretty fast. So this horse's day is going to go from bad to worse. And of course, we all feel sorry for the horse. But anyways, I hope you enjoyed the problem. And more importantly, I hope you understood how to solve the problem. Okay, so this is an example of where we have one-step equations all over science and physics, etc. So if you understand those inverse operations like we talked about in the lesson, you should be fine. Okay, so keep working hard. We'll see you soon.